Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. We would like to tell you about our group project, which is Sandakan Basin Prospect. So this is our group members, as myself, Fatul Fitarmizi, Muhammad Rias, Dana, Faisal, and also Karin Emrisa. So we move to our content. We'll explain about the introduction, population history, tectonic history, stratigraphy and correlation, petroleum system, estimated reserve, and also potential Sandakan Basin. So we move to the introduction. Sandakan Basin is an offshore sedimentary basin located in the northeast part of Borneo, in the waters of Sabah. We can call it offshore Malaysia. It covers an area of approximately around 10,000 square kilometer, and it's also known to contain a significant reserve of oil and also natural gas. The basin is considered to be the one of the most active hydrocarbon province in Southeast Asia, with several producing oil fields and also exploration and development projects also ongoing. And the main hydrocarbon being formation in this basin are believed to be the sandstone and also shale formation of the Miocene and also Pliocene age. The Sandakan Basin also occurs of ship springs and mud volcanoes on Dan Peninsula and adjacent offshore areas. So basically, this location is more about the offshore. And the Sandakan Basin also known to have a mature petroleum system with several oil and gas fields that have been discovered and are currently in the production. For the main rock of the hydrocarbon in this basin is believed to be the Miocene age shale, with the primary reservoir rocks being sandstone and shale formation of Miocene and Pliocene age. And the trap type in the basins include the structural types such as anticline and faulted anticlines, and stratigraphic such as sandstone channels and also shale diapirs. And the main cell of the hydrocarbon in the basins are believed to be the shale and mudstone formation of the Oligocene and also Miocene age. The Sandakan Basin also has a complex tectonic history and has undergone several episodes of uplift and subsidence with the control of the development of petroleum system. So basically, for the petroleum system, we will explain more about that in the next chapter, in the next slide. My friend will tell you about that. So next we move to the exploration history first. This is our exploration history of the Sandakan Basin. The Sandakan Basin has a long history of oil and gas explorations. The first exploration activity in the basin were conducted around early 1900, but the first commercial oil production did not begin until the 1960s. So since then, the several companies have been involved to exploration and produce activity in this basin. Over the years, several oil and gas fields have been discovered in the Sandakan Basin, including the Kimanis field, the Sabah field, the Kinabalu field, and this field has been developed and are currently producing oil and gas. So the exploration activities in basin have been mainly focused on the Miocene and Pliocene rock formation, which are believed to contain majority of the hydrocarbon in this basin. The exploration techniques that have been used in this basin include the seismic surveys, drilling, and also well logging. So in recent years, the basin continued to be explored by international oil companies and the Malaysian government, and also been activity promoting the explorations and also development of in location of this basin.
Okay, next we move to the next topic is tectonic history. So the tectonic history of the Sandakan Basin can be divided into several stages. The first one is the early Miocene stage, which is characterized by the initial collision of the Sulu and Sunda plates, led to the formation of the first structural features such as basins, anticlines, and faulted anticlines. The second one is middle Miocene stages, which is the characterized by the uplift and erosion of the mountain range, led to the deposition of the main source rocks, the Miocene age shales. The last one is the late Miocene and Pliocene stage, characterized by the continued collision and uplift of the plates led to the formation of the main reservoir rock, the sandstones and shales of the Miocene and Pliocene ages. Next, we go to the stratigraphy and correlation. So, okay, this is our table shows regional stratigraphy of Sandakan Basin. So Sandakan Basin is known for its thick sequence of sedimentary rocks that were deposited in a marine environment during the Miocene and Pliocene. The main rock formation in the basin are sandstone, shale, and mudstone, which were deposited in different depositional environments such as channel, deltaic, and shallow marine. Okay, and the stratigraphy of Sandakan Basin is divided in several formations. The first one is the basement formation, which is composed of metamorphic and igneous rock. So the basement formation in Sandakan Basin refer to the rock formation that are formed at the bottom of the stratigraphy sequence in the basin. Like I said before, and the rock is composed of metamorphic and igneous rock. Next, we move to the second one is Miocene formation, which is composed of sandstone and shale. And the Miocene formation in the Sandakan Basin is referred to rock formation that were deposited during the Miocene period, which lasted from about 23 to 5.3 million years ago. These rock formations are considered to important because for a petroleum system in the basin, because they contain the main schist rock and reservoir rock. And next, we have a Pliocene formation, which is composed of sandstone and shale. The Pliocene formation in Sandakan Basin refers to rock formation that were deposited during the Pliocene period, which lasted from about 5.3 to 2.6 million years ago. These rock formations are considered to be an important part of the petroleum system also. Because also they contain reservoir rock and seal rock. Okay, next. So this is for the graph shows the time section with major sequence boundaries or unconformities in identifies. So for the correlation of the rock formation in the Sandakan Basin is done by the comparing their lithology, like the slide before, and the fossil content and deposition environment. This allows geologists to identify and match the rock formation in different locations and to understand the depositional history of the basin. Okay, that's all from me. I will pass to my friend.
Hi guys, my name is Tanasilan and now I'll explain more on source rock and reservoir rock of Sandakan Basin. So, primarily there were three types of source rocks identified in the Sandakan Basin, which are Miocene age coals, Oligocene age coals, and Eocene age sandstones. However, the main source rock is the Miocene age coals, and the total organic carbon for this kind of source rocks are high with good thermal maturity. And from previous research, we found out that the deposition environment for this source rock is marine. Let's move on to thermal maturity. So in 1984, Tissot and Welt collected T-max data of different types of source rock from two fields, which are Ganduman and Sebahat, from which are from Sandakan Basin as well. Uh, the purpose of them collecting this data is to find the oil and gas window. And from their research, they found out that the oil and gas window for these two field is from 430 to 470 degrees Celsius. Now let's move on to the kerogen type and hydrocarbons generated. If you take a look at the graph, you can see that for Sabahat, the source rocks have a low liptinite mackerel presence and low hydrogen index, which means that they can only produce type 3 kerogen, which is not suitable to produce oil, and the source rock potential is only limited to gas. However, in Ganduman, the source rocks exhibit high liptinite mackerel presence. Hydrogen index is also high, and thus the type of kerogen produced by this source rock is type 2 and type 3, which has a potential to produce oil and gas. Now let's move on to the reservoir rocks. So the primary reservoir rocks in the Sandakan Basin are believed to be sandstone primarily, and of the Miocene and Pliocene age. So these rocks have found to be having a good porosity and permeability, which allows them to store and transmit hydrocarbons. So there are 6 different types of sandstone identified from Sandakan Basin, which are poorly bioturbated HCS sandstone, moderately bioturbated HCS sandstone, poorly bioturbated SCS sandstone, well bioturbated Hamaki cross stratified sandstone, interbedded HCS sandstone with sand silt mudstone, and heterolytic mudstone. So these are the identified rock layers, which for identified rock layers. However, out of these 6, only 4 were suitable to be reservoir. So if you take a look at the first one, which is poorly bioattributed HCS sandstone, the color indicates the color of the rock, which is pale white. And if you see, it has a good porosity. However, the permeability is quite low compared to the rest of them. Thus, it is unable to produce good quality reservoir. Next up, we have poorly bioattributed SCS sandstone, which is slightly gray in color, and the porosity is good, and the permeability is great. So, and the thickness is also quite large, which is 10 meter, which indicates that this rock layer is a very good quality reservoir. And then next up, we also have well bioturbated HCS sandstone, which is also slightly grayish in color, which has a high porosity, and the permeability is lesser compared to the poorly bioturbated SCS sandstone. However, it's still good enough to form a good quality reservoir. And finally, we have the interbedded HCS sandstone with sand silt mudstone, which has a porosity and permeability higher compared to the previous layer. However, the thickness is quite low. That is why we've ranked it below the well bioturbated HCS sandstone, which has good quality. So out of the 4 different layers chosen from the 6 sandstone layers before, only the poorly bioturbated Hamaki cross stratified sandstone is unable to produce a good quality reservoir. So that's all from me. Thank you.
Hello, Doctor and everyone. My name is Karen Ambasagoni, and I will continue the petroleum system presentation. Start from trap, timing, and then migration. So for the trap styles in the Sandakan Basin, it includes the structural traps such as anticlines and faulted anticlines, and stratigraphic traps such as sandstone channels and shale diapers. They are characterized by changes in the rock properties such as porosity, permeability, and thickness. Sandstone channels and shale diapers are examples of stratigraphic traps that are known to occur in the Sandakan Basin. Next is timing. So the timing of hydrocarbon generation, migration, and trapping in the Sandakan Basin is closely related to the basin's tectonic history. And several episodes such as uplift subsidence have been identified and controlled the development of the petroleum system. At the right-hand side of this slide is the petroleum system events chart. The basin is believed to have been formed during the Miocene and Pliocene as a result of the collision of the Sula and Sunda plates. And then the main source rock in the basin, the Miocene age shales, were deposited in a marine environment during the Middle Miocene period. And the organic rich shales were then buried and subjected to high temperatures and pressure, leading to the generation of hydrocarbon. These hydrocarbons were then thought to have migrated upward through the rock formations and were trapped in the reservoir rocks and seal rocks. Next is the migration. So the migration in the Sandakan Basin refers to the movement of the hydrocarbons from the source rock to the reservoir rocks. It is believed that this migration occurred primarily through the process of primary migration, in which the hydrocarbons move from the source rock to the reservoir rock while still in a liquid state. The hydrocarbons are generated in the source rock by thermal alteration of organic matter and then migrate through the overlying rock formations to reach the reservoir rocks. And the secondary migration, in which the hydrocarbon move in a gaseous state, is less common in the basin. The timing and direction of the hydrocarbon migration in the Sandakan Basin is controlled by several factors, such as tectonic activity, the depositional environments, and also the rock properties. Tectonic activity in the basin has created several structure features such as anticlines and faulted anticline, as we have discussed before, which have controlled the direction of this hydrocarbon to migrate. And also the depositional environment, such as channels and rivers, have also influenced the migration of these hydrocarbons, providing the pathways for the hydrocarbons to travel. So that is all for me. My colleague will continue the presentation. Thank you very much.
Okay, so I'm Muhammad Riaz. Today I'm going to present about the estimated reserve of Sandakan Basin and the potential of Sandakan Basin in nowadays. The estimated reserve of oil and natural gas in the Sandakan Basin are not publicly available. However, it is known that the basin contains significant reserves of hydrocarbons and has been the focus of exploration and production activities by a number of companies. And the basin is considered to be one of the most active hydrocarbon province in Southeast Asia, and it has several producing oil fields and several exploration and development projects are ongoing. The size and exact location of the hydrocarbon reserve can vary depending on the exploration and production activities, and the discoveries and the commercial viability of the fields. And it is worth that involves in several factors such as the size, the location of the field, the characteristic of the rock information, the production rate, and the commercial viability of the field. Therefore, the exact reserve for the Sandakan Basin are not publicly available, just like I said before, and the information might be held by the companies that are involved in the exploration and production activities in the basin. Next. Okay, so we move to the potential Sandakan Basin in nowadays. Oil exploration and production in Sandakan Basin is currently ongoing. The basin is considered to be one of the most active hydrocarbon province in Southeast Asia, and several companies are involved in exploration and production activities in the basin. Several oil and gas fields has been discovered in the Sandakan Basin, including the Kimanis field, the Sabah field, and the Kinabalu field. These fields are currently being developed and are producing oil and gas. The production rate of the fields varies, but it's expected that the production will continue for several years. Exploration activities in the basin are mainly focused on the Miocene and Pliocene rock formation, which are believed to contain the majority of the hydrocarbons in the basin. Exploration techniques that are being used in the basin include seismic surveys, drilling, and well logging. These techniques are used to identify potential hydrocarbon-bearing formation to determine the size and quality of the reserves. The Malaysian government has been actively promoting the exploration and development of the basin, and it has implemented policies and regulations to attract investment and promote the growth of the oil and gas industry in the Sandakan Basin. And lastly, it is worth to be mentioning that the exploration and production activities in the Sandakan Basin are expected to continue in the future, as the basin is considered to have significant hydrocarbon resource, and the ongoing exploration activities are expected to increase the understanding of the petroleum system and lead to discovery of additional hydrocarbon resource. Okay, next. Okay, that's all from my group. Thank you. Okay.